In this video, I'm going to show you how to make a simple first-person shooter type game. I started out with my general layout. I'm going to build my world real quick. I'm going to add a plane and scale that up and give me some space to work with. I'm going to add a material to this. I'm going to call it ground. And actually, why don't we make the ground brown? Have dirt colored ground. And go down and turn off the specular lighting so it's not shiny. What does that look like? Okay, a little dark. Change my light to sun. I'll call it sun. I'll do strength 2 just so it's well lit. Yeah, that's pretty well lit. This is my ground. This is going to be my player. Let's move him up here. I'm going to resize him so he's about the size of an average human being. So let's say we want the X to be forward, maybe 1/4 of a meter thick, 1/2 meter wide, and 1.7 meters tall. And I'll snap this to the face of my ground. GZ, move that down so he's standing on the ground. And I'm going to go down to viewport display. And I'm going to set him to bounds because we're not going to really see the player. This is just going to be my collision detection. So I'm going to go to physics. I'm going to make sure he's invisible. I'm going to give him character physics. I'm going to turn on collision bounds. For the time being, let me go back and adjust this so we can see him. See, stand on the ground. Yes. There is our boring player, but again, we're not really going to see him. This is more just for collision detection. The camera, I'm going to rename the player camera. I'm going to reset. I'm going to reset the rotation. I actually want it facing which direction? 90 up and 90 this way? Nope, that's facing the other way, -90. I'm going to reset this to 0, 0. And the height of my camera, I'm going to make 1.6 meters. So kind of just below where the top of my player is. Maybe where the eyes were. I could even go down to like 1.5 or something like that. There we go. I'm going to shift click my player and go parent that. Control P, parent to object. Alright, so now we have our camera parented to our player object. I'm going to add some very basic movement logic to my player. If I look inside here, this is actually going to be my player body. I'm going to switch to the Logic Bricks editor. I'm going to do a couple things. On the camera, I'm going to add an always sensor. Always, always. And I'm going to hide the mouse. Set the visibility to false. I'm going to add a mouse sensor. Let's say move. So whenever we move the mouse, I want to look. And the way I do that is I add a mouse actuator. I'll call this look, and I'm going to change the mode to look. And for the camera, I'm just going to use the y-axis. The camera can move up and down. Those are kind of like my head or eyes. It's not going to affect my collision detection. Let's see if I could do this. So P for play. All right, I can look up and down and nod. Yay. All right. However, for the XY, or spinning on the Z-axis motion, I'm actually going to add a look to my box, my collision detection box, because I want my box to turn when I look left or right. So I'm going to add movement and move, or actually and look. When the mouse moves, I'm going to have a mouse look. I'm just going to use the x-axis for this. And I need to actually add something to look at. Otherwise, it'll be very difficult to tell that we're rotating around. So I'm actually going to add my target here. So I'm going to add a sphere. This is eventually going to be my target. But for right now, I'm going to, let's say, move it up 2 meters and then move it along the x-axis. So it's in front of us. All right. So if I press P for play, I can look up and down, I can look left and right. And looking left and right adjusts the orientation of my body, but also adjusts the hit detection for my body as well. And what this lets me do, I'll just show you very quickly, is I could add a keyboard sensor for W. If I press W, and let's say I want to move forward, and add some motion in the X direction, 0.3. Connect this all up. So now if I press play, from the camera perspective, if I press W, I move forward, but if I turn this way, I move forward in whichever direction I'm looking. So I can move the other way away from the sphere and turn back and look at the sphere and move towards the sphere again. And then you can add the other motion to your player cube as well. Strafing, moving backwards, and jumping. I'm going to skip that for the time being and focus more on the mechanics of the first-person shooter. All right, let's add a quick HUD. And the way I found that works easiest for me is I create a new scene. I'm going to call it HUD. I'm going to create a collection called HUD. And I'm going to pop to the X-axis up here. I'm going to add a camera. And I'm just going to move this up a little bit. So grab Z-axis, move it up, jump to my camera. I'm going to switch. I'm going to call this HUD camera so I know which one's the camera I need to use. And what else was I going to do? Oh, I'm going to turn this to orthographic. I'll need to adjust the scale here in a little bit, but that should be fine for the time being. Okay, so we need to add a crosshair or reticle here. You could draw one and import a picture and you add that to your heads-up display, or you could kind of draw one here in Blender. So what I can do is add a plane, and I can scale this down. And say I want the X to be, I don't know, 4 centimeters, so 0.04. And the Y to be, I don't know, 2 millimeters, 5 millimeters, 0.005. You have to zoom way in to see that. Or maybe that's how big I want it. Maybe I want it a little bit bigger than that. 2.5 millimeters high. All right. Reticle horizontal or reticle X. And let's say I copy this and rotate it 90 degrees. That could be my reticle Y. And maybe I want to give this texture, reticle. Let's say maybe I want red. I could do traditional black, but that's kind of boring. Ready to move to specular lighting. I can reduce the alpha a little bit, maybe 0.65. You can see through it a little bit, and I can add some emission. Maybe my reticle glows in the dark. Whoosh. And that actually eliminates, if I add that, that eliminates the need to add lighting to my HUD. But you may want to do that anyways. I'm going to apply my reticle here. Let me just see what that looks like. Ooh, it's very small. Okay, so this is where we need to kind of adjust our zoom a little bit. So camera, there you go, down to 3. And it's still smaller than I want. Actually, what we should do is add some text to see what the text looks like. Okay, so if I were adding text, I think usually what I want to do is like a 30 zoom about, and that seems a little far, 20 zoom. Something where the text shows up pretty good as is, and I don't have to make too many changes to it. So that means I'm going to have to scale up my reticle. I'm actually going to parent these together. Because if I press play, yeah, you can barely see that. All right, so going actual size didn't work as well as I thought. Let's scale that up. 50 seems too big. Let's say 25 times what it was before. Yeah, okay. That should work. So that's my HUD. And then what I need to do is I need to add an instance of this HUD to my scene. I can do that again by going to Scenes and then finding the HUD collection and saying, right-clicking on it and saying Instance to Scene. Now, if I look around, you'll actually see the HUD show up on my level, and I don't want that to happen. So I'm going to switch back to View Layer, and I'm going to go to HUD and click the eyeball on it. So this will hide the HUD, but I will still be able to access it and apply it to my camera. So if I go to my camera, I already have an always on here. I'm just going to add a collection actuator. Call it HUD. And I want to reference the HUD collection I just added. I want to say add overlay. And I want to use the HUD camera link that up. All right. Now we're getting somewhere. So, how do we detect hits? Well, I'm going to first go to my target. I'm going to give my target its own material target. Let's make these, maybe I want these to be black and shiny. Maybe up the specular lighting and up the metallic. Maybe right click on this and shade smooth. That did not work. Shade smooth. There we go. There we go. Nice shiny black target. How do we detect a hit? Well, what we can do is we can shoot a ray out from the camera. I want to determine what the front end of the camera is. And the easiest way I found to do that is to change transfer options to local and then switch to the movement tool. And then you'll see the arrows representing Z, Y, and X, blue, green, and red respectively. So Z, positive Z, is actually facing inwards towards the camera behind the player. So the ray we want to shoot should be in the negative Z direction relative to the camera. So I'm going to add a sensor, ray, and I'm going to change the axis to the negative Z axis. And what I want to do is I want to detect a hit with the target property. There's a couple, or a target material. There's a couple ways to do this. As always with collisions, you can either do properties or materials. And I want to detect a hit when I click the mouse button. I'm just going to make that a tap. I'm going to need a Python controller here. And I'll show you what that Python looks like. I haven't found a way that works really, really well. Specifically, if you're going to make multiple instances of your target to use just the node blocks. It is possible if you have, individual targets to use just the node blocks and say, okay, if I hit this target, get rid of it. If I hit this target, get rid of it. If I hit this target, get rid of it. But you'll have lots and lots of logic you have to add because you'll have to add the ray. You'll have to add array for each target, and then you'll have to add logic to move each or get rid of each one of those targets as you hit them. So using Python, what we could do is create a new collection for our target, which I will also call target, and move our target into that, and then we can actually make multiple instances of our target. Let's go ahead and do that. So if I right click on target and say instance to scene, and maybe I'm going to move this in the grab Y direction, move it over, and I will add another instance and grab Y and move it here. So if I look at my camera, I have 3 targets I can hit now. All right. So let's set up our target logic. What I'm going to do is add a property to this target. Hit. I'm going to make that a Boolean, and that's going to be false. And this is how we're going to detect our hit. We're going to set this property for the target that gets hit to true. So we need a property is hit. I'm going to check to see if hit equals true, capital TRUE. And if that happens, then I want to hide the target. You could set the visibility or end the object but both of those cause lag, and ending the object is actually a little bit buggy if you restart the level. So the quickest and easiest and least buggy way I found is to just kind of move the target out of the view port or out of view from the user. So we can shove this down 50 meters, move it underground. So if this hit property gets set to true, this target will move 50 meters underground. We won't see it anymore. You could do something else with this. You could have it play an animation or, add a reactionary motion to the object when it gets hit. But for now, I'm just going to hide it. So that sets up our logic because these are instances. All three of these targets share the same logic. If you set the hit property for any one of these instances, it will activate the hide motion. All right, so back to the player camera. We have the ray, we have the mouse click, we have our Python. I'm just going to add a property here to track the number of hits. I'm going to make this an integer. And we could display this on the screen so we could see what this looks like. So whenever my Python triggers, I'm going to say +1 hits. I'm going to set that to add mode. Hits and add 1 to that. All right. So let's look at what our script looks like. So if this is my first script, I'm going to click the plus new. I'm going to add a hit script. Import my BGE. From BGE, import logic. Don't know if I'm going to make a whole lot of use of that in this, but I've kind of gotten used to it at this point. I'm going to grab my current controller, get current controller, and I'm going to grab a list of sensors for my controller. Cont.sensors. Now I want to check if all sensors are positive. So sensors have a state, either they're positive or negative. There's a separate property triggered, which gets set to true immediately when the sensor becomes positive, but then triggered gets set to false right away. So you don't necessarily, it's very rare to have two sensors that get triggered at the same time, immediately at the same time. So even if you check the ray and the mouse sensor and you try to check for triggered, you'll see that, oh, the ray sensor triggered, but the mouse didn't, and the mouse sensor triggered, but the ray didn't, even though you clicked on an object. So what you really want to check to see is if both of those sensors are positive. Did we click the mouse, and did we shoot a ray and intersect with an object that has the target property? So what I'm going to do is I'm going to use some filtering. I'm going to build a list of negative sensors. Negative sensors. And this is just kind of a standard one-liner. What we're doing is we're grabbing a list and we're filtering. And I'm going to use what's called a lambda function. Lambda allows me to write an inline function. And I'll explain really quickly what that does. S.positive sensors. So, my lambda function has a parameter s. My lambda function is going to return a Boolean value, not s.positive. It's going to check the positive property of this s, which stands for sensor, and it's going to return the inverse of that. And it's going to do that for all of my sensors that are listed here. So I'll end up basically with a list of negative sensors. If I didn't click the mouse, that will show up in the list. If my camera is not currently pointing at an object, my ray sensor will show up in the list. So then it becomes very easy to say, okay, if not negative sensors. It's called self-documenting code. If I don't have any negative sensors, that obviously means all the sensors are positive. Then what I want to do is mark objects as hit. I'm going to build another list using that one-liner again. Rays equals list filter lambda s. And I'm going to check if s, sensor, is instance of what's called a bge.types SCA underscore array sensor. Is the sensor array sensor? I'm going to do that for all sensors. Now, I currently only have one ray sensor, but you're never quite sure which sensor is going to be the ray sensor in the list. So this just kind of scans through the list of sensors and finds the ray sensor, or finds if you have multiple ray sensors, it'll find all the ray sensors. But you could do this using the name of the ray. I say name of the sensor and say, okay, I want the sensor called ray, and that's the one I want to check. But this is much more scalable. It allows you to make changes to your sensors and you don't have to make changes to the code. But it does make the code a little bit more complex than maybe you need it to be. But then I could just do this. For ray in rays, I want to say ray, the object that was hit, and that's hit object. And then I want to set the property hit to true, capital T-R-U-E. So for every ray that ends up in the list, if the ray has a hit object, we're going to set that property to true. And then for good measure, I'm going to activate my actuators. Say for act in controller cont.actuators, cont.activate act. And what this does, this will just trigger my +1 hits property over here. So back on this page, I'm going to set my Python controller to hit. And let's try this out. Let's zoom in a little bit. So I'll bring this down here. Full screen. All right. And my objects, it's kind of hard to see the hits property up in the left corner. But if I click, nothing happens. And that's because I forgot one step in that the ray sensor starts out with a extremely short range, 10 centimeters or 1 centimeter. So it's not very far. I'm going to increase that to 50. I probably should maybe be able to hit something at 50 meters. All right, let's try this again. Boom. Come over here. Boom. You can kind of see up in the top left-hand corner, hits is incrementing every time I hit an object, and they're disappearing one by one. Boom. All right. So that concludes this video. Thanks for watching and happy blending.